Good morning, guys. This is chapter 9.5. Today we're going to be covering the area of sectors and the area of segments of circles. So here are your lesson objectives. Make sure you copy them down and let us get ready to go. Okay, so what is the sector of a circle? The sector of a circle is a region bounded by an arc of the circle and the two radii or radii to the arc's endpoints right here. So this shaded area is called a sector of a circle. Okay, and we're going to be looking at how to find the area of a sector. So here we go. Approximate equals to basic decimal solution. So the first one, we're going to just do an approximation. Anytime they say approximate, that's the easy part because that's just putting it in the calculator and making sure you round correctly. All other than that is all good. So just like before when we were finding the length of the arc, basically is the same here, except that instead of circumference, you're going to use the formula for area of a circle. So first we want to find zeta, and zeta divided by 360 degrees times the area of the circle. In this case is pi radius square, and that's going to give you the area of the sector. This is going to give you the area of the sector. In this case, they gave me that zeta was 105, so 105 degrees divided by 360 degrees, and then pi, the radius is 6, so that's 6 square. That should give me the area of the sector, right? So that's 36 square, or I'm sorry, 36 pi times 105 divided by 360. If you take that and reduce it, let's see, 105 that gives you that is 7/24. So 7/24 times 36 pi should give me an approximate, because we're going to approximate, right? So that's what I'm going to do. So here we go to that times 36 pi. Look at the pi button right over here. And that gives me that is a total of about 32 and 99 hundredth, and that would be in square feet. So 32 and 9900 square feet. That's my actual or an approximate area. Okay, that's an approximate area. Okay, so what if I wanted exact? It says here exact is the same as live in terms of pi. So basically here is the zeta. Zeta is 60 degrees. If I divide 360 or 60 divided by 360, that means this is about 1/6 of the whole circle, right? So that would be 60 divided by 360 times pi r squared, which is pi, and the radius is 12 meters square. So that would be 1/6 of 144 pi. In other words, 144 divided by 6. So I'm going to take that. It says 1/6 times 144. I leave pi alone because I'm going to leave it in terms of pi. And that would be 24 pi. So the actual area exact will be 24 pi, and then look at the units, it's square meters. So the area of this sector right here is 24 pi square meters. Okay? Okay, the next part is how to find the segment of a circle. A segment, as you can see, is when I have this chord right here where it touches the two points in the circle and leaves a segment, that's called a segment. It's part of a circle bounded by an arc and the chord joining its endpoints. So what you see here, how do I find that? Well, basically, if you think about it, is you take the area of the sector, subtract the area of a triangle that is formed by that segment, and then what you will have is the segment left. See, you take the area of the sector and subtract minus the triangle that is left, then you're going to be left with an area of the segment. So let's take a look at that and what it would look like when we are doing the exercise. Here is an area of a sector. So what I want to find is this whole sector first. I want to find the whole sector. So let's do that. Okay, so what I want to do is to find first the area of the sector, which is from this central angle, which is 60, right? This whole thing. And that is given by zeta divided by 360. And that times the area of the whole circle, which in this case is pi 8 squared, minus, since this is a triangle right here, I want to look for my apothem right over here, which would be a hexagon, right? Because this is 1/6. If I take 60 divided by 360 times pi 64, this right here is 1/6 of 64 pi. Basically, it would give me the area of the sector minus the area of the triangle. Remember the triangle, if I cut this in half with an apothem, this would be a 30 right over here, 60 over here, and my 90 degrees. Now, these two are congruent. That would be the side of a hexagon. Basically, if this is 8, which is the hypotenuse, half of 8 would be 4, and then the long leg would be 4 square root of 3. So the long leg is 4 square root of 3, and this side right here, since this is 4 and this is 4, it would be 8. Right? So what do I have? For the area of a triangle is base times height divided by 2. So it's 8 times 4, which is 32 square root of 3, divided by 2. 32 divided by 2 is what, 16? So 16 square root of 3, and that's square centimeters. That would be the area of this triangle right here. Okay, so if I take this, subtract the area of the triangle, the area of the sector minus the area of the triangle will give me the area of the segment. So let's go to the calculator in a sec. And I put that, it's 1/6, or you could do it in your mind. Here it's 1/6 and 64 is 64 divided by 6. So 64 divided by 6 pi, and then subtract 16 square root of 3, and that gives you that about 5.8 or 5.8. It's about 5.8 square centimeters. So that's the area of this sector right over here, or this segment, I'm sorry. Okay, so that's how you do it. That's how you find the area of the segment. Take the area of the sector minus the area of the triangle. It will give you the area of the segment. Okay, the next part is to find the area of a segment of a circle, this time leaving it in exact measurement. So first you find the area of the sector, which in this case this is 90, so it's 90 divided by 360, and the area of the circle will be pi radius square. Okay, that would be 1/4 of 16 pi, which is 16 divided by 4 is 4 pi, right? Then minus the area of the triangle. Remember, if I take the apothem, but I didn't have to, it would be a 45. So if this is 4 and this is the hypotenuse, the sides or the legs will be half of that times the square root of 2. So that would be 2 times the square root of 2 over here. This would be 2 times the square root of 2 over here. So the whole thing would be 4. So the base is 4 square root of 2 times the height, which is the same as 2 square root of 2. All of that divided by 2. That would be the area of the triangle, right? So 4 times 2, that's 8. So this is 8 times the square root of 4 divided by 2. Well, the square root of 4 is 2, so this is the same as 16 divided by 2, which is 8. So 4 pi minus 8 square meters. That would be the area of the segment. Right there, that's the exact measurement. Alrighty, so make sure you summarize your notes and go practice.